So yesterday we learned to draw an ellipse using tangent lines within a directing circle. And if you remember in our example yesterday, the major axis length we set to be 10 centimeters. And we put the foci, we marked out 4 centimeters from the center so that they're 8 centimeters apart. And with a quick calculation, I can actually calculate the minor axis because I know that 8 squared plus the minor axis squared must equal 10 squared. So I can write that out. 8 squared plus b squared will equal 10 squared. That's 64 plus b squared equals 100. So b squared must equal 36, and b must equal 6. So my minor axis is 6 centimeters long, but another question might be, where exactly is it? And I can find that using my straight edge and my triangles. And so let's brace from the side. Take my right triangle. And I have to use my sight to try to see where the top of the ellipse would be. But since my major axis is horizontal, my minor axis is going to be perfectly vertical. And so now that I have this braced here, I'm going to go ahead and slide it over. My minor axis would be this line going right through the center. Now I'm just going to mark it with a dotted line because that's not what we're most interested in today, but it is valuable to see that we can find it. And what may be more interesting is to note which of the tangent lines are tangent to the minor axis. So there would be a point here and a point at the bottom with a tangent line running through it. If you can see, there's actually one drawn here. And what may or may not surprise you is that that tangent line is the one that goes vertically through a focus and then horizontally through the minor axis. So if you can tell, my triangle is actually perfectly vertical going through F1. And I could go through F1 to the top. And again, I'll find the exact tangent line. It's perfectly horizontal that goes through the top of the minor axis. Okay, but our interest today, beyond the ellipse, is actually drawing something else. We want to see if we can use the same directing circle method, but now to draw a hyperbola. So I want to do one thing first. I want to extend my major axis, but just for the beauty of my page, I'm not going to make this very dark. I just need it for reference. So I'm going to make a really light extension of this diameter, which I'll be erasing after I make use of it. So we'll just extend that out a little ways, and a little ways, and you'll see what I'm going to do. I want to try to find a hyperbola that has some similar characteristic to this ellipse. So I'm wondering, the distance from this vertex to this focus is 1 centimeter. What if I go 1 centimeter in the opposite direction? So I'm going to come back here, and even though I found this focus by going through the center of the circle, I can now move from the vertex to the outside of the circle. Make the mark, and then do the same thing on the other side. So putting the point of my compass right against the circle and my line, I'm going to make a mark on the extended line. Go ahead and darken those in so you can see. And since I've already used F1 and F2, I'm going to name these F3 and F4. Great. I can erase the line. Don't actually need that, I just need the point. I can even erase what's before it. I can come back later and touch that up a little more. But the method for the hyperbola is very similar. Again, I want the right angle of my triangle to stay on the directing circle. It's like it is hooked to this outer circular rim, and it's just going to rotate around. But I also am going to keep one leg running through one of the foci. So to start, I'm going to use F4 and put my right angle here against the circle, but I'm not going to draw that line. Instead, I'm drawing the line on the other leg. And so this line is just going to come straight out and off the page. And I'm going to keep rotating. Again, I can use my pencil to pivot, move the right angle, and draw a new line. So let's draw 2 or 3 of these and see what we have. So here you can see some of my lines are crossing, but for the most part, they're just starting to extend off the page. But if I keep going, so this new line has crossed all the others. But this one that I'm drawing now is not, it's crossing these at the bottom, but it's not coming out here. But you can see right now, if I was to travel along the topmost part of the lines, I'm certainly starting to turn inward. But we're wanting enough lines that we actually start to see a curve. And so quickly you can see that the new lines I would be drawing here are not going to reach far enough to influence that curve. So that's a sign that I might want to move to the other focus. And this is the part that's probably most tricky, because I want my right angle to be on the circle, the other, one of the legs to go through F3, and then I'm actually drawing along the leg that appears to go through the circle. But I have to make sure I keep this right angle on the circle. So it can be a little tricky to find where your limitations are, where your lines would be. All right, I'm finding a line now. I can tell this line is going to cross into new territory, so that's going to be an interesting line. Now I'm not going to draw through my old ellipse. I'm going to wait until I get outside the circle and draw here. Again, getting more and more lines. Wait till I'm outside the circle. You can see I'm starting to get a little bit more into this other territory. So I'm going to keep working at this. Notice that there's a place here where I can get a perfectly horizontal line. It's still interesting, even though this isn't new territory, it's still interesting to see the movement of the lines. So it gives us something to kind of see, and it helps our eyes track out the curve that's starting to form. Now, much more is going to form actually as I flip over and move into this realm. So see, here I am going through F4. I'm going to go up to the top. Maybe I want to start with something that's almost vertical. Keep making my way around. I'm starting to get a picture of one side of the hyperbola. I'm also going to be working on this other side. So I'll show some pictures of where I come to, but notice that just like for the ellipse, I have two foci, F3 and F4 now, and I actually have two vertices. It's the same vertex that I had for the ellipse. I'm making this hyperbola meet the ellipse right on the edge. Thank you.